In this video we are going to talk about spherical mirrors. The previous video was about plane mirrors. A simple definition of a spherical mirror will be, it is nothing but a reflecting portion of a spherical surface. Now, to tell you exactly what do I mean by this, let's have this example. Suppose you have a glass sphere. You have a glass sphere, and then what you do is you silver the outer surface. You can imagine you have the option of silvering the outer surface or the inner surface. Here you can see I have silvered the inner surface. Now if you cut this sphere, this away, the shape of the remaining part is going to look like this, where this is the outer surface which has been covered. You will notice that the inner surface is a smooth reflecting surface such that light can be incident on it and the inner surface can reflect light. This kind of mirrors is what is known as a concave mirror. You have already represented this in your earlier classes like this, and that is quite fine. We'll stick to this. So basically your outer surface is covered and then you have your inner surface which can reflect light. Here if you take the glass sphere again, and not the outer surface, inner surface is silvered, covered. Now again if we cut this and remove this portion, the leftover portion is going to look like this and the inner surface is covered. That means the outer surface of this sphere now can reflect light for us, and such mirrors we call them convex mirrors. Representation will be this, where you have a curved surface. Notice the inner surface of that curved surface is covered and you can reflect light from the outer surface. Let's quickly look at the definition. A mirror made by silvering the outer surface of the part of the hollow glass sphere such that the inner surface of the hollow glass sphere reflects light is what we call as concave mirror. Similarly, convex mirror is a mirror made by silvering the inner surface of the part of the hollow glass sphere such that the outer surface of the hollow glass sphere reflects light. Now you don't need to memorize this, you just need to remember which surface of the sphere is going to reflect light, and depending on that you can distinguish between your concave mirror and convex mirror. Now to get into more detail of it, we have to understand the various terms related to spherical mirrors, and we should do it properly right now because later you will see that you will come across with lenses and you will have similar kind of terms again. So better to go right now once, have a proper discussion about the properties or the terms related to your mirrors, both concave and convex, get proper understanding and then proceed. So here are the different terms related to our spherical mirrors. First of all, we have this center C, which we call center of curvature. Now this center of curvature is the center of the sphere from where we have cut out our mirror. You already remember our mirror was cut out from a sphere. Now that sphere should have some center. This is the center of curvature. Now proceeding to your actual mirror is here. This point is just in space. There's nothing here. Actual mirror is this. Now if you take the center of the actual mirror, we call it pole or pole of the mirror. Now we have axis called principal axis, which we get by joining the center of curvature and the pole. It is an imaginary line. After principal axis, we can define another point called focus, which basically lies on the principal axis if our mirror is uniform in shape. Now what is this focus? To understand this focus, we have two different definitions of this focus. One is for your concave mirror and one is for your convex mirror. For the concave mirror, let's look at this example and understand what is focus. Here we have a concave mirror As I told you earlier, the inner surface is going to reflect light. The incident ray that we have, I have drawn parallel to our principal axis. This is the principal axis. This is the principal axis, and we have drawn incident rays parallel to our principal axis. When these rays, they strike these points, notice this is the point of incidence, this is the point of incidence, even this is the point of incidence. After striking the mirror, the rays are going to bounce back. Now again here also, even in your spherical mirrors, I must draw a normal here and here at the points of incidence. Right now I'm not drawing them, but that will be somewhere around here. I'll show you how this normal is drawn. But for the time being, this is the incident ray and this is our reflected ray. Again, if you see this ray now, this ray is also incident parallel to our principal axis. After hitting the surface of the mirror, you can again imagine a normal being drawn here. This ray is going to pass again or reflect back from the mirror. Notice this is the point where the two reflected rays are going to meet, and this is what we call as focus of your concave mirror. So basically what focus is that it is the point at which rays incident parallel to the principal axis after reflection from the concave mirror will pass through. Similarly, if you look here at the convex mirror here, now if you take the incident ray again parallel to the principal axis, these rays are going to bounce back again following the laws of reflection. Now this reflected ray and this reflected ray obviously will not meet along this direction, but they appear to meet somewhere here. So this point here, now we will call it focus of your convex mirror. This point basically means when the ray of light is incident parallel to the principal axis of our convex mirror, after reflection the rays appear to diverge away from this point, and that is what is a focus is. Moving forward, we have radius of curvature, which is not a point but a distance between the center of curvature and the pole. The gap between the center of curvature and the pole is called as radius of curvature. Then we have focal length, which is basically the distance again between the focus of the mirror measured from the pole. So basically we are talking about two distances here. Let me just show you. The distance of the center of curvature measured from the pole is called radius of curvature. Distance of the focus from the pole of the mirror is called focal length of the mirror. You can understand that some mirrors are going to have more focal length, some mirrors are going to have less focal length, and even your radius of curvature can be large or small. One last quantity that we may need is your aperture. In the diagram, aperture is shown by mm'. Aperture basically means the size of the mirror. It is taken from the extreme end of the mirror to the other extreme end of the mirror. So you can understand that some mirrors have big apertures and some has small apertures. If you want to see big objects, you will need a mirror of big aperture. Whereas if you need to see small objects, you will need a mirror of small aperture.